Okay, let's dive right into it. Welcome back. In this explainer, we're going to investigate a genuine manufacturing mystery. Today, we're giving you a complete overview of our second session's focus, which is all about data-driven cost calculation. We're going to break down the core metric of manufacturing, uncover those sneaky physical traps hiding on the factory floor, and explore the advanced data systems used to track literally everything. We'll be using these calculations to expose the hidden operational leaks that are quietly draining a factory's profitability. So if you've ever wondered where the money actually goes on a production floor, well, you are definitely in the right place.
Which brings us to a really fascinating paradox. Why exactly do costs rise when your raw material prices haven't changed a single cent? It's a scenario that frustrates managers all over the world. You check the global market, prices are totally stable, yet somehow your final product cost has inexplicably crept up. Well, the answer to this mystery doesn't lie in the market. It's actually hidden deep within the factory's own data. It's right there in the physical reality of the production floor.
Let's move to Section 1, the core of cost management, known as the unit. To solve our mystery, we really need to introduce our first major clue. We're getting right to the core of cost management here, looking at a concept known in the manufacturing world as the unit or wondeni. Now, the unit isn't just some basic math formula. It's the exact amount of resources, whether that's raw materials, electricity, steam, water, or chemicals, invested to yield exactly 1 unit of a product. Think of it as the ultimate undeniable evidence of a factory's true operational efficiency. Basically, if this number goes up, your efficiency has gone down. It is the absolute ground truth of your manufacturing cost. Let's look at a super quick mathematical example just to make this concrete. Imagine your factory inputs 520 tons of raw material into a process, and you yield 500 tons of the final product. So you just divide the input by the output. 520 divided by 500 gives you 1.04. What does that mean? It means that for every single ton of product you create, it costs you 1.04 tons of resources. And here's the kicker. Even a microscopic increase in this unit value, when you multiply it across thousands of tons, creates a massive spike in your manufacturing costs. So the really crucial point here is how you look at this unit data. If your costs are rising, looking at the factory's overall average is a complete trap. It just blends all the data together and hides the real culprits. A true manufacturing detective knows you have to conduct a process-by-process analysis. You have to isolate the reaction process from the separation process and separate that from the drying process. Only by comparing the unit at each specific stage can you pinpoint exactly where that operational leak is actually happening. Moving right along to Section 2, the traps of production and silos. Now that we know what to look for, we need to figure out where the data gets distorted out there on the physical factory floor. And this brings us to a massive misconception: production versus packaging. A lot of folks treat these as the exact same thing, but honestly, this is a fatal analytical error. Production is the act of making the product. Packaging is the act of getting it ready for the customer. In a real factory, there is a huge time gap between these two events. I mean, what you boxed up today might have literally been produced last month. So if you treat your daily packaging volume as your daily production volume, your unit calculation is going to be completely wrong. Because of that critical time gap, we have to follow the actual flow of the product. After the manufacturing process, the product doesn't just magically teleport into a cardboard box. It sits. It moves into intermediate storage spaces, like a silo. It waits there until it's finally time for packaging, and only then does it move to shipping. Understanding this physical flow is absolutely essential because it proves that products are often just resting in hidden spaces on your factory floor, completely throwing off your daily numbers. To account for that time gap, we need a totally foolproof formula to calculate actual production. And here it is. Actual production equals your ending inventory minus your beginning inventory plus your monthly packaging volume. You strictly require tracking those inventory changes. Let's say you packaged 500 tons this month, but your silo inventory grew by 10 tons. Your actual production was actually 510 tons. If you only use that packaging number, your unit calculation would be artificially inflated, leading your management team to make some pretty terrible decisions based on bad math. To use that formula correctly, you have to track what I like to call the hidden suspects. These are work in process, or WIP, which are half-finished goods, silo inventory, sitting in temporary storage, and packaging stand inventory, which is boxed up but hasn't actually left the floor yet. Failing to account for these specific mid-process inventories will entirely derail your unit calculation. They are the invisible variables that will totally ruin your data integrity. And among all those suspects, the silo is definitely the most dangerous. The silo is essentially an invisible inventory trap, a physical black box. Because the product is enclosed in there, it is highly prone to measurement errors, omitted data, and system mismatches. Seriously, when a factory's data doesn't add up, the very first place a good detective looks is the silo, because it's the primary source of missing volume on the entire production floor. All right, on to Section 3, Data Flow and System Utilization.
So how do modern factories actually stop these leaks and track everything perfectly? Well, they use advanced forensic IT tools to establish an airtight, data-driven cost management system. You see, data doesn't just appear out of nowhere. It has a strict three-step life cycle. First, it starts with the P&ID in the design phase. Second, it moves to the DCS for live collection. And finally, it rests in the RTDB for storage and historical analysis. If you want accurate costs, you absolutely must have integrity across all three of these steps. Let's break them down real quick.
First up is the P&ID, which stands for Piping and Instrumentation Diagram. Think of this as the master treasure map for your data measurement locations. It dictates exactly where every single flow meter, pressure gauge, and temperature sensor is placed on the physical pipes. Now, if this map is wrong, like if a sensor is installed on the wrong location, all subsequent data is hopelessly compromised right from the get-go. You just can't fix bad physical placement with good software. Now, if the map is correct, the sensors feed that data into the DCS, the Distributed Control System. This is your live evidence gatherer. It is continuously pulling raw flow and pressure data from the factory floor in real time. But it doesn't just monitor, it calculates the cumulative flow of materials over time. This continuous stream of live, ground truth data is the exact mathematical input we need to accurately calculate our unit cost. Finally, that live data gets sent to the RTDB, the real-time database. This essentially acts as the factory's historical archive. By storing all this timestamp data, the RTDB allows us to cross-reference current anomalies with historical trends. Say your unit cost suddenly spikes today. You can just look at the RTDB trend graphs to pinpoint the exact minute the flow rates changed. It allows you to find the precise moment an operational inefficiency started. It's like having a time machine for your factory data. But, even with these incredible systems, human error still creeps in. So here is the final verdict. The most frustrating real-world errors that will destroy your cost calculations if you leave them unchecked. Number 1, ignoring silo and WIP inventory. Number 2, treating packaging volume as actual production volume. Mismatching measurement units is a big one too, like trying to calculate kilograms against tons without converting them first. Or using inconsistent timeframes, like comparing daily inputs against monthly outputs. These sound like simple mistakes, but they will completely invalidate your entire data system.
Which brings us to our final question and something I want you to really think about after today. Is your company looking at accurate data right now? As we've seen, accurate cost calculation isn't just about being good at math, it's about verifying the physical reality of the factory floor, from the invisible inventory hiding in the silos to the exact placement of sensors on a pipe. So I challenge you to look past your financial formulas and verify your physical data flow, because at the end of the day, accurate data creates accurate costs, and accurate costs drive the absolute best decisions. Thanks so much for joining me on this explainer, and hey, I hope this sparks some really great conversations at your next operational meeting.